The GMV was developed to fill a definite need for a more compact, lighter weight, pre-assembled engine. It is built in 4, 6, 8, and 10-cylinder sizes, designed to save the buyer money, time, trouble, space, and maintenance. If it does those things, you will agree it is a better engine. Well, let's look at the facts. The GMV is more compact. A big item in the cost of any compressor is its size, reflected somewhat in the problem of shipping and hauling, but particularly in its housing requirements. When you are laying out a new plant or revamping an old one, this difference becomes acutely apparent. For example, these shaded portions represent the size of the foundations required for 3 of the ordinary inline vertical engines. And these represent the foundation requirements for GMVs of the same capacity. Less floor space, and consequently less building required to house them. It comes to you already assembled. It has been run in, fully tested, and okayed at the factory before you get it. 10 minutes after a GMV is installed, it can be doing business at full capacity. And consider for a moment the importance of the ease of movability. If you ever want to change locations, think of the simplicity of moving the shorter, more compact GMV. But how, you may question, can you get more horsepower into less space? First, by using the 2-cycle principle. Greater horsepower per inch of cylinder diameter. Secondly, by advanced engineering. Consider the superior V-type design. A sketch to quickly illustrate. 2 cylinders on 1 crank throw double the horsepower without increasing the length. So naturally, this V design for any given number of cylinders greatly reduces the overall length of the unit and at the same time shortens the crankshaft, making it much stiffer torsionally and with fewer bearings. That is why a V engine may be built in more cylinders than an inline engine. But what about the wear of V-type cylinders? A question that used to crop up occasionally in the past. Won't the weight of the piston due to gravity thrust wear the cylinders out of round? No, sir. As a matter of fact, the explosive power thrust is so tremendous by comparison that it completely swallows up the negligible gravity factor. Thus, the cylinder wear rate of the V-type engine, or even the horizontal type, is definitely no greater than in the best vertical engines. The jaw-type base, or open-side one-piece frame, is more rigid, yet more accessible. The use of cast meionite in the base adds further to its strength and rigidity. And since the main bearing shells are split vertically, it is possible to install or remove the crankshaft through the side without disturbing the cylinders, an advantage that cannot be overestimated. Sturdy but easily removed tie pieces complete the frame housing. Like all Cooper Bessemer completely assembled units, the GMV comes with precision bearings throughout. In turn, that means precision boring of the main frame over its entire length, equal precision machining from one end of the crankshaft to the other, grinding connecting rod bores to an exact tolerance, and bearing shells finished to extremely close limits. In other words, much better bearings, always, that will definitely carry higher loads than is ever possible with any hand-scraped bearings. Thus, another advantage, and a big one, is the ease with which a bearing in the GMV may be removed and replaced in the field without scraping. In fact, all GMV parts are interchangeable. Just think of the added advantage that affords. So you see, replacing a bearing in the GMV requires no hand fitting, and it'll be ready for a full load immediately afterwards. As we have already seen, the GMV crankshaft is considerably shorter than in other type engines of like capacity. We know that the shorter the crankshaft, the greater the torsional rigidity, as demonstrated with this model. Note the twist and vibration frequency of a bar of this length compared to the frequency of this more rigid, shorter bar. In an engine, this means a wider speed range without vibration. But even on top of that, the GMV shaft has an unusually large diameter compared to its length, making it all the more rugged. It, of course, has long cylinder centers for accommodating a large diameter compressor cylinder on every throw, yet is still very short overall compared to the same power in an inline engine. The crankshaft is counterbalanced to eliminate shaking forces and ensure smooth operation. An important decision had to be made in the original design as to whether the connecting rods should be individual, that is, side by side on the shaft, or articulated. Side by side, they lengthened the crank pin and reduced its torsional rigidity. On the other hand, the articulated rod made possible mounting both power rods, as well as the compressor rod, on one large bearing, simplifying the bearing setup and greatly reducing the bearing pressure. So the articulated rod was decided upon, helping that much more to get a short, rigid crankshaft. It also allows for all three cylinders that work together, the pair of power cylinders above and the compressor cylinder at the side, to be more efficiently right in line rather than offset. Since the GMV is essentially a compressor unit, and since the compressor load on the crank pin may readily be greater than the power cylinder load, the compressor rod is used as the master, with the two power rods linked into it and the pins bolted to them. This patented pin construction is another exclusive feature, and important indeed. Used at each end of the articulated power rods, it affords twice the bearing area otherwise possible, and thus again greatly reduces bearing pressures. The pistons themselves are plated, with metal having excellent bearing qualities, eliminating scuffing and making long running-in periods a thing of the past. And remember, these pistons are oil-cooled by Cooper Bessemer's unique cocktail shaker principle, a feature of all Cooper Bessemer engines. Plated pistons, and this method of cooling pistons, are important factors in our long, trouble-free operation and exceptionally long wear of cylinders and rings. Since compressor cylinder diameters dictate comparatively long cylinder centers, a main bearing is provided on each side of each crank throw, thereby putting two main bearings between each pair of crank throws. Since there are two main bearings to each rod, we can send the cooling oil up through one of them, and by double drilling the connecting rod, back down through the other. Like all Cooper Bessemer engines, the GMV is noted for narrow piston rings. Behind these narrow rings are years of research and field experience. Due to their low inertia, ring groove wear is reduced to practically zero. But more important still is the reduced ring friction on the cylinder wall. Last but not least, see how much shorter the ring section of the pistons can be made with these narrower rings. Think of the advantage that is in lower reciprocating weight. The two-cycle principle permits the most simple cylinder head design. This has been worked out to provide even stresses and thorough cooling. Cracking of these cylinder heads is practically unheard of. The secret of a good two-cycle power cylinder is in the porting. In the GMV, this is the result of years of research and provides thorough scavenging. Please note that there are no water grommets or gaskets between the head and the cylinder. Instead, the GMV is equipped with water jumpers on the outside. Any leaks that might develop are plainly visible and can be remedied without removing the head. The crossheads of the GMV are unusually large and husky to transmit the load of the compressor cylinder. Perfect scavenging of the two-cycle engine is one of its most important features. Let's see how the GMV handles it. Since it is already a compressor unit, it is logical that the scavenging piston should be a part of the compressor drive here on the crosshead, obviating the necessity of separate cylinders for blowing out the burnt gases ahead of each new charge. The GMV engine, as a gas engine, is provided with Cooper Bessemer's perfected gas injection, known as the silent Scott injection system, affording fuel economy equal to 4-cycle performance. The gas injector assembly is designed so that the cylinders can be balanced with a simple adjustment of a needle valve without disturbing tappet clearances. Just listen to the difference. Here is the old-fashioned clankety-bang type. Now the silent Scott. Experience reminds you that when you're hearing undue tappet noise, you are hearing unnecessary wear. Frequently, multi-cylinder engines are designed basically wrong in the driving of auxiliaries, such as lubricators, governors, air starting valves, and ignition distributors, from the free end of the crankshaft. On the GMV, the auxiliaries are mounted on the free end of the engine, but connected with a lay shaft to the drive located as near as possible to the flywheel, freeing it from the torsional deflection present in all multi-throw shafts. Just another case of better design, longer life. A complete engineering service on control systems is provided for the various GMV applications. These systems enable you to govern automatically the speed and unloading of your engines in any combination, thus affording perfect control of pressure, flow rate, time cycle, torque, or other desired functions. For example, Cooper Bessemer's patented wide-range speed control is applied to these 24 1,000 horsepower GMVs in one of the world's largest synthetic plants. A word about the miracle of convertibility, and we're through. Since there were so many fields for this compressor where fuel gas was not available, this engine was first designed as a diesel. When used as a gas engine, therefore, it has strength and to spare. So the GMV is convertible, but mere convertibility is not enough. The GMV has an ease of conversion that comes close to being a miracle. Since both the fuel injection pumps of the diesel and the gas injection valves of the gas engine are driven from the crankshaft, both injection cams can be furnished right on the engine. And all the change that is necessary can be made right here on the cylinder head. No change necessary within the crankcase. Here is an engine that has been running on gas. To change over to diesel, all you have to do is remove the cylinder head insert from each head. Substitute the fuel oil insert, which automatically converts the compression chamber. Tighten it up, turn on the fuel oil, and you're running a diesel. And that's all there is to it. We could go on about Cooper Bessemer ignition, the special Cooper Bessemer oil conditioning system, and so on ad infinitum. Of course, we shall be glad to answer fully any other questions. Meanwhile, we are more than willing to rest our case on the following outstanding points of Cooper Bessemer superiority. The GMV is more compact. It is a two-cycle engine. It comes to you already assembled, saving time and installation costs. It has much greater ease of movability. The GMV has V-type cylinders, saving floor space. Its open side one-piece frame is more rigid and more accessible. The GMV has interchangeable precision bearings throughout, longer life. Its connecting rods are articulated, less bearing pressure. Plated pistons, no scuffing, less running in. The GMV has oil-cooled pistons and narrow piston rings, less maintenance. Its crossheads are unusually large and husky. It has perfect cylinder scavenging, higher thermal efficiency. Only the GMV has the famous silent Scott injection system, fuel economy. Auxiliaries are lay shaft driven, no vibration. With it comes complete engineering service, automatic control, and a miracle of convertibility to gas or diesel. An engine that had any one of these features would be a better engine. The GMV has them all. Gentlemen, Cooper Bessemer presents with pride the GMV.